Good afternoon to Dr. Ashikin and my fellow friends. We are from Group 3 for the subject STF2083 Scientific Communication. Our group consists of me, Holly Anak Rasiam with the metric number 73491, Natalie Chong F0339, and Nurin Katina Zahra binti Sarbini 78476. Today, we will be presenting our research proposal on the study of feasibility of crude glycerol as a feedstock for production of lacase by Pichia pastoris. This is the overview of our presentation today. The first one is introduction. Crude glycerol is a waste product from the creation of biodiesel and is one such promising feedstock for multiple processes in the many industries. In this study, the focus is given on the use of crude glycerol as feedstock for Pichia pastoris in lacase production. It is done by fermenting Pichia pastoris with different concentration of initial crude glycerol, temperature and pH as the parameters. Next, the activity of lacase is estimated using a spectrophotometer at 420 nanometer. By the end of the study, it is expected that the ideal concentration, temperature and pH for fermentation of lacase using crude glycerol by Pichia pastoris will be determined.
Thank you, Holly. My name is Nurin Katina and I will present about the research background. So, there are 5 main points that have been highlighted in our research background. The first point is the increasing focus on investigating renewable energy and natural sources stems from the urgency to address climate change, reduce reliance on fossil fuels, and transition towards sustainable practice. This investigation aims to explore viable alternatives that can provide clean energy and sustainable materials for a more environmentally conscious future. The second point is the crude glycerol's potential as a feedstock lies in its affordability and accessibility, as it is a byproduct of biodiesel production and widely available. However, it is important to address environmental concerns associated with its utilization, ensuring proper waste management and minimizing any adverse impacts on the environment. The third point is the catalytic capability of lacase make it a valuable enzyme for a wide range of industries, including pulp and paper, textiles, pharmaceuticals, and environmental sectors. Its potential applications encompass lignin degradation, dye decolorization, pollutant removal, and synthesis of valuable compounds, making it an attractive tool for sustainable industrial process. The fourth point is the exploration of alternative sources and ecological feedstocks for lacase production is necessary due to the high cost and limited availability of this enzyme. By identifying sustainable and cost-effective production methods, such as utilizing renewable resources or optimizing microbiosystems, the barrier of cost and scarcity can be addressed, facilitating wider adoption of lacase in various industries. The last point is to determine the feasibility of using crude glycerol as a feedstock for lacase production with Pichia pastoris. Further investigation is needed. This research aims to evaluate factors such as enzyme properties, lacase yield, and economic viability to assess whether crude glycerol can be a viable and sustainable alternative feedstock for lacase production using Pichia pastoris. The next part is hypothesis and problem statement. On the hypothesis, utilizing crude glycerol as an alternative feedstock for Pichia pastoris will result in viable and cost-effective lacase production. In addition, exploring alternative and ecological feedstock for lacase production will overcome the limitation of high cost and scarcity. For the problem statement part, the high cost and limited availability of lacase hinder its widespread uses in various industries, calling for alternative and sustainable production methods. In addition, improper disposal of crude glycerol, which is a waste product from biodiesel creation, poses environmental concerns. Finding new uses for this waste stream high in glycerol becomes crucial to address this issue. Next part is objective. There are 2 objectives in our proposal. The first one is to study the effect of crude glycerol on lacase production by Pichia pastoris. The second one is to determine the ideal concentration, temperature, and pH for fermentation of lacase using crude glycerol by Pichia pastoris. I will discuss about the first part of literature review, which is crude glycerol. Glycerin, also referred to as glycerol, is a byproduct of the esterification process used to make biodiesel. According to Raza et al. in 2021, the biodiesel industry alone accounts for 66% of the world's glycerol. The use of crude glycerol as an affordable feedstock is demonstrated to be very viable or suitable for a few thermochemical conversion processes, including pyrolysis, gasification, combustion, liquefaction, catalytic steam, and supercritical water reforming. Next, according to Du et al. In 2019, why Lepoletica prefers glycerol as a carbon source compared to glucose? Group glycerol that contain either sodium hydroxide or potassium hydroxide increases proliferation by 1.5 to 2-fold. Crude glycerol with sodium hydroxide work well to produce hydrologous alpha amylase, which is 3.5 unit per milliliter in 30 hours. Next, according to Carroll et al. In 2020, different technologies for glycerol conversion were discussed, which are biological conversion, chemical conversion, thermochemical conversion, and catalytic conversion. The second part of literature review is about lacase. For your information, there are many applications of lacase within our industry. According to Singh and Gupta in 2020, application of lacase in our industry such as pulp industry, food processing, as well as dust and textile industry. Meanwhile, according to Mayolo de Loza et al. In 2020, lacase has its application towards manufacture of drugs like analgesic, sedative, anti-inflammatory agents, and antibiotics. The second point of this slide is about the production techniques, whereby there are two types, which are fermentation, submerged fermentation, and solid-state fermentation. The third point of this slide is about genetic engineering approach, whereby the synthesis of recombinant lacase heterologously by utilizing constitutive expression system. For instance, recombinant lacase from the expression of PGAPZ alpha A lec2, fusion of constitutive expression vector PGAPZ alpha A with lactogen from Pleurotus ostratus in Pichia pastoris X3. This is according to the Song et al. In 2020. Next, I will pass to the next presenter. Thank you.
In this slide, I will talk about Pichia pastoris. Pichia pastoris have been widely used to produce recombinant proteins for various applications. In the literature by Liu et al. In 2015, lacase gene for Thermus haemophilus strain HP27 that was expressed in Pichia pastoris had high yield and was exploited for its decolorization properties. A more recent study conducted by Niederhaus et al. In 2018 managed to produce lacase of Pignoporus sanguineus origin that had high thermostability and functional at broad pH range. It can be used in fermenting lignocellulosic waste into sugars. Now I'll be presenting our research methodology. Pichia pastoris strain X33 will be cultured in shake flask containing YPD medium at condition of 220 round per minute rotation at 30 degrees Celsius for 24 hours. The culture will be checked of its OD value until the ideal 0.5 to 0.6. Then it will be centrifuged to obtain the seed culture in the form of pellet. Next, it will be standardized to 10% volume per volume concentration and fermented in YPD media at 220 round per minute rotation. Initial crude glycerol concentration, pH, and temperature are our focus parameters. For crude glycerol, concentrations between 20 to 60 grams per liter will be supplied to the media for 36-hour fermentation at pH 4.6. In study the effects of pH ranging from 2.0 to 7.0 will be provided to the media and left for fermentation for 96 hours at 30 degrees Celsius. For the last parameter, which is temperature, the culture will be grown at temperature ranging from 10 degrees Celsius to 70 degrees Celsius and maintain a pH 4.6 for 1 hour. After the fermentation process ends, the crude lacase will be led to oxidize APTase for 5 minutes at 30 degrees Celsius and then analyzed using spectrophotometer at 420 nanometer. This is the last step. That's all from me. Now I will pass the stage back to Holly. Thank you.
Thank you, Natalie Chong. Next is expected outcomes. By the end of this study, the effect of crude glycerol on the lacase production by Pichia pastoris will be studied. This includes the role of crude glycerol as main carbon source for growth, metabolism, and lacase production. The most important thing is the ideal concentration, temperature, and pH for fermentation of lacase using crude glycerol by Pichia pastoris will be determined. Last but not least, the work schedule. Upon receiving the title of study, literature review will be started in August 2023 and proposal writing and presentation are expected to be done in October 2023. Following that, the experiments are expected to start and finish by February 2024. By May 2024, report writing and presentation are expected to be done. These are the references used in these slides. That's all from us. Thank you.